welcome to Maths Chat. I'm going to be going over in this video how to find the gradient of both perpendicular and parallel lines, and also talk about the difference between these two. To find gradients of lines that are parallel or perpendicular to other lines, it's important to use some formulas to help us along. So I've written this out and I'm going to talk through it so that you can have a better idea of the relationship between parallel and perpendicular lines. So parallel is when the gradients are on the exact same angle. So these two lines will never ever touch. Now whenever you've been told that two lines are parallel, it's quite straightforward because we know that the gradient of one will equal the gradient of the other line. And that is why we use the formula m1 is equal to m2, where m represents our gradient. So m1 represents the gradient of the first line and m2 represents the gradient of the second line. For perpendicular lines, that is when you've got something that looks like this scenario. So see how the pen makes a 90-degree angle with the ruler? So that is the case that has happened here along this line. And the second line sits perpendicular to the first line. To solve the gradient of a line that is perpendicular to another one, we need to find the negative reciprocal of the gradient of the first line. So we use the formula m2, being gradient 2, is equal to negative 1 over m1, being the first gradient. This can also be written as m1 times m2 is equal to negative 1. Alright, so let's put that to the side so that this can help us answer the questions. So we're trying to find the gradient of a line that is parallel to this line. And you'll notice this is not in a form that makes it easy to see what the gradient is. So I'm going to rearrange this formula into the form of y equals mx plus c. Because as you know from previous videos, when it's in this form, whatever m is, the value that's multiplied by x, is my gradient. So 3y minus 2x is equal to 3. To start off, I'm going to try to get my x term, and my constants on the same side, constants being the numbers. And also I'm going to try to get the y by itself on the left hand side. So to start off, I'm going to add 2x. So I'm left with 3y is equal to 2x plus 3. The final step is to divide the left side by 3. This means that I'm left with an equation of y equals 2x over 3 plus 1, because 3 over 3 is 1. Looking at my first equation, I can see that m is equal to 2 over 3, 2/3. So using the fact that m1 is equal to m2 for parallel lines, we can say, therefore, m2 is equal to 2 over 3. And that is the answer for that question. Now where we've got perpendicular lines, there's a couple more steps. Again, I'm going to start by rearranging this formula, because the first step is to find m1. Let's start off with the original equation, and then term by term I need to make sure eventually that I've got y by itself on the left side and my x term and my constant on the side, not with the y. So let's start by subtracting 7x, which leaves me with negative y is equal to negative 1, negative 7x. Now I don't want that negative in front of the y because that's still not in the form of y equals mx plus c. So I'm going to divide by negative 1 to cancel it out, which means I also need to divide the entire right side by negative 1. This leaves my equation as y is equal to positive 1 plus 7x. Now since the gradient is whatever is multiplied by my x when it's in this form, m1 is equal to 7. Now let's have a look back at this formula. m2 is equal to -1 over m1, or m1 times m2 is equal to -1. Now, since this is the formula where it's already rearranged from here, I'm going to use this one. So if m2 is equal to -1 over m1, and m1 is 7, m2 is equal to -1 over 7. And that is the gradient of my line that is perpendicular to 7x minus y and equal to -1. So that was parallel and perpendicular lines. Hopefully you've understood the difference between them. Make sure that you leave any questions and feedback in the comment section below, and also subscribe to the channel. I'll see you later.